So for today's video, we have got a video on alkanes and alkenes. So we are starting off with alkanes. So you see these alkanes here. They have single bonds. So these lines here represent the single bonds between the carbon and hydrogen. So we have methane here, ethane and propane. These are all saturated due to them having single bonds. And if you're asked for the formula of them, you just count how many carbons they have, and then you do 2 times the number of carbons plus 2. So we have an example, we'll have 1 carbon here, 2 times 1 is 2 plus 2 is 4. So now moving on to alkenes. These alkenes are different to alkanes due to them having the double bond, as you can see here. So these are now known as unsaturated due to the double bond. And now just for the general formula of them, you count the number of carbons. So 2 carbons here. For hydrogens, 2 times the number of carbons here. So just give an example of these different alkanes you can have. Methane, you know the structure of them and the formula. We will go down for methane, ethane, propane, butane, and pentane. And this all relates to the number of carbons I have for the names. And the general structures are here. And now we move on to what isomers are. So isomers are the compounds that have the same molecular formula, but they have a different structure. So, for example, we have butane here, which you saw from the previous slide, but a different structure of it is methylpropane, where methyl group is in the carbons and the propane there, and the methyl group here. So as you can see here, the same general formula, but it's just a different structure. Moving on to what can be attached to carbons are functional groups. So we've got alkanes, which you've seen as single bonds, alkenes, which have a carbon double bond. So we've got examples of methane, ethene, and now a different functional group now is an alcohol. So instead of a hydrogen, it can have an OH group attached to the carbon. An example here is butanol. In your time, you might see some complex molecules, and you'll have to be asked to name them. So a way of doing this is just select the longest unbranched chain of the carbons there is, and then you number the chain from where the branching starts first, or where the functional group is, and then you just list the branching groups and functional groups alphabetically in the name, including a number where the carbon in the chain they are attached to. And now something important is to test for alkenes, and a good test for this is the bromine test. So bromine water is an orange solution of bromine. It becomes colorless when it reacts with an alkene. Alkenes can decolorize in bromine water, but the alkenes can't. So to differentiate between these two, you use a bromine water test. This is known as an addition reaction, and the bromine is decolorized because a colorless dibromo compound forms with the alkene, which shows that it's an alkene.